Hello everyone, and then welcome to another video. In this video we are going to talk about the principles of mathematical induction. Okay, so in simple terms, we are trying to prove an expression relating to an equation. Okay, so we are just using a certain portion of the equation to prove the other side of the equation, of the same equation. Okay, but what we have to know is that we have to pay much attention to the operation sign. Okay, something like this. Okay, so let's take this for example. I'll try as much as possible to make this video as short as possible and at the same time very concise, so I'll just go straight to the point. Okay, so let's take this example. So we can see that we have a sequence over here and then with an expression. Okay, and then that equates to another expression. Okay, so what we are trying to do is that we are trying to prove that this left hand side is equal to the right hand side. Okay, pair the operation sign. Okay, so let's start off with an initial value of n. Okay, let's say n is equal to 1. Okay, since n is equal to 1, we have to pick a single value from the left hand side. Okay, right. Before I move on, okay, I would urge you to subscribe to the channel so that you don't miss out on any newly uploaded videos. Okay, so let's just get right into this video. Okay, so let's pick n equals 1. Since n is equal to 1, we have to pick only one value from here. So we have 3, okay, is equal to the right hand side. So since n is equal to 1, it means that every n we see in this expression will be replaced with 1. Okay, so we have 1 and then 2 multiplied by 1. Okay, sorry, 2 multiplied by 1, okay, plus 1. Okay, and from this expression we could see that this gives us 3. Okay, it means that the left hand side is equal to the right hand side. Okay, this is a base case, so this is correct. Okay, let's move on. Let's pick another value for n. So let's say n is equal to 2. Okay, it means that we are picking two values from this side. Okay, so we have 3 plus 7. Okay, should be equal to the right hand side. Okay, so we have 2 open brackets 2 multiplied by 2, okay, plus 1. Okay, from here you can see that this equates to 10. Okay, which is equal to 3 plus 7. Okay, you know that 3 plus 7 is also equal to 10, right? So it means that the left hand side and the right hand side are equal. It means that the proof is correct. Okay, so let's move on to picking n. Okay, picking another value for n. Okay, so let's say n is equal to 3. Okay, so we have picking 3 values from here. Okay, so we have 3 plus 7 plus 11. Okay, should be equal to this expression. So we have 3 open bracket 2 multiplied by 3 plus 1. Okay, so when we do this calculation, you can see that this is 1, this is 21. Okay, and then let's look at this side too. So 11 3 7, this is also 21. Okay, yes, so it means that the left hand side and the right hand side are equal. Okay, so from this principle you could see that our proof is correct. Okay, both the left hand side and right hand side are equal. But one thing you have to know is that this wouldn't be always true. Okay, sometimes picking higher values like maybe n is equal to 15, okay, might require very high values in order to prove that the induction process is true. So that's where we invent a certain expression, okay, to prove that the left hand side is equal to the right hand side. That's proving the principle of mathematical induction. Okay, so let's take a look at this example. Okay, let's say we have a certain expression as, let's pick, okay, so let's pick the same expression. Okay, let's just pick the same expression, this same expression, but I want it to be a bit simpler so that you'll get to understand the whole concept and its simplicity. Okay, so let's pick a simple expression like picking x, okay, is equal to a certain sequence, okay, okay, to maybe, let's say n, okay, to be equal to n plus 1, okay, then you close the bracket, then divide by 2. Okay, so let's see something right here. From here you could see that we have another expression. Okay, so just like the previous example, so we are trying to prove the principle of mathematical induction. Okay, so first let's pick a value for n. Okay, let's pick n to be equal to 1. So picking n equals 1, so it means that we are picking one value from here. It could be any value, it could be 3, it could be 2, it could be 1. So let's just pick 2, okay, from this sequence. So let's say from the left hand side we pick 2 to be equal to this expression. Okay, so we know that n is equal to 1, so we are replacing 1 with n. So we have 1 open bracket 1 plus 1 divided by 2. Okay, this will give us okay, let's pick 1, n equals 1. Okay, and then it means that we are picking only 1. Okay, so we have 1 equals this expression. Okay, so we have 1 open bracket 1 plus 1, okay, divided by 2. Okay, so from here we have 1 plus 1, that's 2, multiplied by 1, that's 2, divided by 2, that's 1. Okay, you can see that the left hand side is equal to the right hand side. We could do the same thing. Okay, picking n to be equal to 2. Okay, so we have picking two values, that's 1 and 2. We have 1 plus 2, okay, equals this side we have 2 open bracket 2 plus 1, okay, divided by 2. So we have this will give us 3 by 2 is what, 6. That's 6 on 2, this is equal to 3. Okay, and then we know that 1 plus 2 is also equal to 3. Okay, so it means that the right hand side and the left hand side are equal. It means we have proven the principle of mathematical induction. Okay, so what if we want to prove the same principle for very high values? Okay, all you have to do is just use a certain variable, let's say k. Okay, so let's assume that n is equal to k. Alright, okay, so we have for the example we could just pick this expression. Okay, so we have s of k, right, should be equal to 1 plus 2 plus 3 plus certain values to k, okay, to be equal to k, open bracket, k plus 1, okay, divided by 2, okay. So from here, since we've used a certain value to replace n, we could also use a certain value to replace the previous value for n, okay. So something like, we know, let's say k is equal to 20. We are proving for 20, the 20th term, okay. So what if we could also prove for the 21st term? Okay, that's why we have n to be equal to k plus 1, okay. Yes, so when we have a certain expression like this, all you have to do is just insert it into the expression, okay. So we have s equals k plus 1, okay, which should be equal to the same expression. So we have 1 plus 2 plus 3 plus k, okay, plus this expression, okay. So we have k plus 1, okay, and then this should be equal to this expression, but since n is equal to k, that's why we just replace the k with n, okay. But for n equals k plus 1, we are replacing all the k's with k plus 1, okay. So we have k plus 1, okay, and then we open our brackets, and then we have k plus 1, okay, I have k plus 1, okay, then plus 1, alright, and then we divide that by 2, alright. So let's look at a simple scenario over here. Okay, so we could see that this whole expression, okay, this entire expression from here to this side, okay, is the same as this, right? Okay, this entire expression, okay, this entire expression is the same as k multiplied by k plus 1 divided by 2. So we can just replace that, okay, with this, okay. So it could be k, open bracket, k plus 1, okay, divided by 2, and then we add this one, okay. So plus k plus 1, okay, and then we could see that it's the same as this, okay. This is the same as this expression, okay. Okay, so we have k plus 1, okay, and then we have the same expression as k plus 1, okay, plus 1, right, divided by 2, okay. So when you expand this, okay, you get this, right? So you can see that this left hand side is equal to the right hand side, okay. Yes, this is how the principle works, okay. So in order to prove that the left hand side is equal to the right hand side, we have to arrive at a certain answer, just like this, okay. So from this we could see that the principle of mathematical induction is very, very true, okay. Again, instead of going through this entire process, okay, you could just use a calculator approach, okay. You could just use a calculator approach to arrive at the same answer, okay. we just use a calculator approach to arrive at the same answer. So in the next video, I'll prove to you how to use calculator to get the exact values or the exact proof. That's we want to know that the left hand side is equal to the right hand side. Okay, so we'll just use a calculator to prove that. Okay, there's no need to do this sort of calculation trying to prove the mathematical induction of right hand side being equal to the left hand side. Okay, so let me further break this down. You know that we end up arriving at the same answer. Okay, let's try to prove this side. Okay, so we have this, okay, to be equal to okay, let's prove for the left hand side first. Okay, no, the right hand side. So we have k plus 1. Okay, so open bracket is k plus 2, right, divided by 2. Okay, and then let's look at the right hand side, no, the left hand side. Okay, so we have k squared, right, plus k, okay, divided by 2 plus k plus 1, right? Let's move on. So from here we could see that we have when you divide this side by 1, okay, let's use this approach. When we divide this by 1, you will get k squared plus k, alright, plus 2, okay, multiplied by k plus 1, alright, divided by 2, okay. Then we have k squared plus k, alright, plus 2k plus 2 divided by 2, okay. And then we have, further simplifying this, we'll get k squared plus 3k plus 2 divided by 2, okay. So we could see that we've expressed this in the simplest form. Okay, so let's look at the right hand side. Okay, so we have this multiplying this. Okay, we have this, we have k squared, between nectar we have k squared plus this by that will give us 2k, right? This by that will give us k, and this by that will give us 2 divided by 2, alright. And then we move on. Okay, so we have k squared plus 3k plus 2 divided by 2, alright. So you could see that it's the same thing, right? K squared plus 3k plus 2 divided by 2. So you could see that both the right hand side and the left hand side are equal. This is what we mean when we talk about the principle of mathematical induction. Okay, the left hand side has to be equal to the right hand side. Note, in the next video I'll show you how to solve this by not going through all this stress. Okay, I'll just show you how to use the calculator to arrive at the same answer. Okay, especially when you are working with multiple choice questions. Okay, multiple choice questions. Okay, so I will see you in the next video. But before I go, I'll urge you to please subscribe, and then hit on the bell icon so that you don't miss out on any uploaded videos. Okay, see you in the next one. Bye bye.